In this video, I teach you a stage of combustion in CI engine, means compression ignition engine, and compression ignition engine means it is the diesel engine. So in a diesel engine, the only air is supplied during suction stroke and the diesel is spray at the end of compression strokes. So various stages is there is generally 4 stages that I explain in this video by using the P theta diagram. Means on a y-axis there is a pressure and on the x-axis this is a crank angle theta. So here you see this diagram, that is a various color line is available. So it's indicate the various stages, okay, that we understand later on. The P theta diagram of a combustion process during the one cycle of CI engine is shown in this figure. Means it is only for one cycle, and this process is divided into the 4 stages as discussed below. Now the first stage is the ignition delay period or a pre-flame combustion. So it is the line A to B, means this line is indicate the first stage, okay. And generally we study the combustion means from the starting of the combustion we understand. So in a CI engine we know that the first is the suction stroke, then compression, then the fuel injection, power stroke and exhaust stroke, okay. But we are studying the stages of combustion, means we start at the point of combustion, and we know that the first the compression is start when the piston is moved from the bottom dead center to the top dead center. That's why we written here that BDC to TDC, then piston to TDC. At that time the power stroke is start and the power stroke is completed at the bottom dead center. So again TDC to BDC. So this is start from the direct compression process. So first stage is the ignition delay period, okay. So in a figure, motoring curve and actual fire cycle curves are shown. So in this figure you see the two line, okay. This one is this curve, that is known as the motoring curve, and the motoring curve I explained during the CI engine. Motoring curve means when the inlet and exhaust valve is closed and no diesel is sprayed, just the compression is takes place and expansion is takes place. This is known as the motoring curve, and this is the actual curve, okay, that is the actual fire cycle curve. Fuel is injected at the point A, so means this blue line is for a compression process, and compression is completed at the top dead center, but we supplied the fuel before TDC, certain angles before to the TDC that we already study in a valve timing diagrams. So fuel is injected at the point A. As soon as the fuel jet is broken into a fine spray, means when we supply the spray inside the diesel engine, okay, so we know that there is a compressed air is available. So compressed air pressure is higher, that is up to the 15 bar or 14 bar. So we need to supply the diesel at the higher pressure than the 15. Then the diesel are able to penetrate inside the air, then its atomization is occurs, then vaporization is occurs. That is generally 3 stages. First the diesel is need to penetrate inside the air, then after is atomization and vaporizations, okay. So we need to supply the fine spray of the diesel, and the fuel start absorbing heat from the surrounding high temperature air, and vaporization of the fuel start. Before vaporization its penetration and atomization is there, and this diesel is absorb the heat from the compressed air, and this compressed air pressure and temperature are higher. The chemical reaction also start as the vaporization of the fuel start. So when the diesel is start to vaporization, so this vaporized diesel is start the chemical reactions with the compressed air, but in absence of flame, because at that time the flame is not available. Therefore it is the known as the pre-flame reaction. So here we need written that ignition delay period or a pre-flame combustion. Means pre-flame meaning is flame is not produced before the time, that is known as the pre-flame combustion. And ignition delay means when we spray the diesel, at that time the ignition is not start. After some time ignition is start, okay, that is at the point B. Here in this image you see that at the point B combustion is start and at the point A injection is start. So this time is known as the stage A. So that's why it is written as the stage A, and it is represented in a term of the crank angle theta. At the beginning of pre-flame combustion, the energy release rate is very less than the rate of heat absorptions by the fuel, because the amount of the fuel vapor is small. Means the what amount of the diesel is spray, that energy release rate is very less than the heat absorption, means the diesel is absorbed the some quantity of the heat. That's why this line is slightly going down, means slight pressure is increased, then again it is increased. This increase in pressure attain in maximum value when the energy release due to pre-flame reaction is equal to the rate of heat absorption by the fuel. Means it reach to point B when the amount of the energy release and the amount of the energy absorbed by the diesels both are equal. Fire cycle curve is start or its differings at the point B from the motoring curve. Means up to this point B, firing curve and motoring curve are same. So from point B, motoring curves are moving this line and the fire cycle curve is moving in this upper directions. The durations between the period A and B is known as the ignition delay period. Means this duration is known as the ignition delay period, that is from point A to B. Therefore, the time required between the fuel injections and the start of actual combustion is known as the delay period. Before moving ahead, I request to like the video and subscribe the channels by pressing the subscribe buttons. And also visit the playlist for watching the various subjects related to mechanical engineering and IC engines, and the link is provided also in the description of this video. Again, the total ignition delay period is divided into two parts, namely the physical delay periods and chemical delay. Means this ignition delay is divided into physical delay and chemical delay. So first we understand what is the physical delay period. During the physical delay period, fuel is injected from nozzle in the form of very fine spray. It is known as the atomized form. The fuel particles absorb the heat from higher temperature hot air inside the combustion chambers and vaporize so that they are well mixed with the air. So this is known as the physical delay period. What is the chemical delay period? After physical delay period, means after atomization of the diesel, after vaporizations and after mixing with the air, chemical delay period is start. So after mixing, the combustion is not quickly starts. Okay. So during this period, chemical reactions between air and fuel is start. It is known as the pre-flame reaction. So these periods end when the fuel auto ignites and flame appear. Means chemical delay is finished when the combustion is start, that is at the point B. So in between A to B, it is divided in two parts, physical delay and then after the chemical delay. So it is very difficult exactly to separate the physical delay and chemical delay period. Generally, chemical delay is longer than the physical delay. However, it's depend on the temperature inside the engines. At the high temperature, chemical reactions is quicker and physical delay is longer than the chemical delay. So this sentence is opposite. So generally chemical delay is longer than physical delay. But when the higher temperature inside the engine, the chemical reaction is quicker. So physical delay is longer than the chemical delay. So delay periods refers to the sum of physicals and chemical delay. In most of the CI engines, the ignition delay is shorter than the duration of injections. Second stage is the uncontrolled combustion. Okay, and the line of this uncontrolled combustion in a P theta diagram is from the point B to C. So this red color line is indicate the uncontrolled. Now what you understand from the meaning of uncontrolled? Means combustion is not controlled in our hand. If we control the combustion, then it is known as the control. But this combustion is not controlled by our hands, then it is known as the uncontrolled combustion. In CI engine, the time and place where ignition will start is not fixed. Okay, in petrol engine it is fixed. When we do the spark, at that time the ignition is start. But in CI engine it is not fixed, because the fuel is continuously sprayed for approximate 30 to 40 degree of crank angle. So here you see the period of injection from this to this. Okay, so it is approximate 30 to 40 degree. So during this delay period, fuel is spread throughout the combustion chamber. The combustion start at any point from one place or many places. Means diesel is completely sprayed inside the combustion chamber. So combustion may be start at any point. It is one single point or it is in the multiple points. Also the combustion is start, means multiple flame is also produced. Therefore, considerable amount of the fuel is accumulated in a combustion chamber during delay periods, and it's burned rapidly and causing the high pressure rise as shown in a curve between point B and C. Means there is a number of point combustion is start, that why the quickly pressure is rise, then it is known as the uncontrolled combustion. As delay period increase, more amount of fuel is accumulated in combustion chamber, which increase the pressure rise and produce the high frequency noise, which is known as the diesel knock. So due to the number of points the combustion is start, due to that reasons the knocking is also created, and knocking is created due to the increase the pressure rise at the different point. As it is not possible to control the amount of the fuel burning during this stage, therefore it is known as the uncontrolled combustion or a rapid combustion, because the number of amount of the fuel burning is not controlled by us, that's why it is known as the uncontrolled combustion. And the third stage is the controlled combustion, and the controlled combustion range is from this C to D points by the dark blue line. So this C to D is known as the stage number 3 and name is the controlled combustion. During this stage, rate of combustion can be controlled by varying the rate of fuel injections. So fuel injection period is from the starting of the stage 1 to this after this end of the stage 3. Means during this stage 3, if we control the fuel injection, then we are able to control the combustion. Okay, that's why it is known as the controlled combustion. The quantity of fuel increase or decrease, the rate of combustion will increase, decrease accordingly. During second stage of combustion, means during the uncontrolled combustion, delay is completed and all the mixture accumulated during the delay period is burned. Therefore, pressure and temperature inside the cylinders become very high. After uncontrolled combustion, whether the fuel injection will be readily get the fast fresh air due to the swirl and instantly ignite without any delay periods due to high temperatures and pressure. Means after this uncontrolled combustion, means after the point C, if we spray the diesel, it's immediately start the combustion. It's not need any delay periods. It's not delay, it's initially start, because during this uncontrolled combustion there is a high pressure and temperature is there. So during this controlled combustion, we supply the amount of the diesel is directly combustion is start. It's not require more time or it's not required any delay periods. Therefore, condition is controlled by the fuel injection rate. That's why this stage is known as the controlled combustion. The heat evolved by end of the controlled combustion is about 70 to 80% of total heat of the fuel supplied during this cycle. Means 70 to 80% of the heat is generated during this period. And the last is the fourth stage, that is the after burning. So for the after burning, this line is D to F. Theoretically, we can say that combustion is completed at the end of third stage. Means at the end of the point D, combustion is over. So controlled combustion is over at the point D where the maximum cycle pressure is reached. So we assume that theoretically that at the point D the combustion is finished. But after this D point, the combustion is there, then it is known as the after burning, because meaning of after burning is that combustion of the fuel after the controlled combustion, it is known as the after burning. But actually small quantity of fuel particles may combust after the point B is known as the after burning. The reasons for after burning may be heterogeneous mixture, poor distribution of the fuel particles, heavier molecules in the fuel. Heterogeneous mixture means that is not a proper combustion, proper mixing of the air and the diesel. It is known as the heterogeneous mixture. But in a petrol engine, it is a homogeneous mixture, means air and petrol is properly mixed. So thank you for watching this video. If you learn, then like the video, subscribe the channels, share with your friends and comment on the video.